Hello, and welcome to another episode of NASA Science Live. My name is Bree Hill, and I'm a public affairs specialist at NASA headquarters, as well as your host for today's episode. Today is International Asteroid Day, and here at NASA, we're watching the skies 24/7. And although today is dedicated to raise awareness about asteroids and what we're doing to protect the Earth, we also want to take a deeper look into how these rocky artifacts are the time capsules of our solar system. Asteroids are known as the geological remnants of the solar system, and they can help us understand how life was formed here on Earth. Today, we are talking to NASA experts about everything asteroids, like the upcoming sample return from a 4.5 billion-year-old asteroid named Bennu, along with missions to the Trojan asteroids, a metal asteroid world, and an upcoming test that will demonstrate a technique to change the orbit of an asteroid in space. Today I'm joined by Dani DellaGiustina, a research scientist at the University of Arizona and the acting Deputy Principal Investigator for the OSIRIS-REx mission, along with Dr. Tarek Daly, a senior scientist and deputy instrument scientist for the DART mission at the Johns Hopkins University Applied Physics Laboratory. Thank you both for joining today.
Thanks for having us, Bree.
Happy to be here.
As you just heard, NASA has a slew of exciting upcoming missions related to asteroids. Can you tell us, Dani, why does NASA have so many spacecraft studying these objects? Aren't all asteroids the same?
That is a great question, Bree. So no, asteroids aren't all the same. These objects are the leftovers of the formation of the planets, and there are hundreds of thousands of these rocky little worlds. Because asteroids formed at varying distances from the sun, they bear the fingerprints of distinct processes that took place across the solar system from its formation until now. And so by studying different examples of asteroids, we can learn quite a bit about the variety of things that have happened in our solar system's history.
Wow. Now, Tarek, do any of these asteroids we're studying have a potential hazard to Earth?
Well, about 100 tons of extraterrestrial material falls on the Earth every day, mostly as harmless dust and the occasional meteorite fragment. More rarely, Earth does get hit by larger asteroids, but none of the asteroids visited by spacecraft pose a specific hazard to Earth.
Wow. Well, thank you so much, Dani and Tarek. We'll be right back with our experts to answer a few more questions. Remember that you too can join the conversation and have your questions answered by our guests using the hashtag AskNASA on social media, or you can write in the comment box wherever you're watching the show today. But first, have you ever heard of the Trojan asteroids? NASA's Lucy mission will launch later this year to visit several of these mysterious objects that share Jupiter's orbit. Let's learn more. Hi, we're joined again with Dani and Tarek. We've heard a little bit about the Trojan asteroids that the NASA Lucy mission will explore, but I understand there's another asteroid-focused mission named Psyche. Can you tell us more about it?
Of course. So the Psyche mission is a journey to a metal world that sits between the orbits of Mars and Jupiter. So for the very first time ever, humanity will explore a world made not of rock or ice, but of metal. And this mission will give us a window into the metallic cores of planets, which lie too deep beneath the surface to ever reach, as well as tell us more about how the solar system formed. And the Psyche spacecraft is slated to launch in summer 2022.
This is so cool. Now, Dani, when we send these spacecraft out to study asteroids, do they bring all the instruments with them? Can we ever bring samples back to Earth?
That's a really good question, Bree, and the answer is yes. We can absolutely bring samples of asteroids back to Earth for study. So returning samples lets us study asteroid material in our laboratories with a lot more detail than we can gather from a spacecraft. OSIRIS-REx is NASA's first asteroid sample return mission, and last year it grabbed a sample from the surface of asteroid Bennu. You can see how wild gathering that sample was in this clip. The sample of Bennu is going to be delivered back to Earth in September of 2023, so we can further study it. And additionally, our colleagues with the Japanese space agency JAXA just returned samples from asteroid Ryugu last December. So JAXA is sharing part of the sample of Ryugu with NASA, and our laboratories are preparing for that really exciting delivery later this year.
Oh my gosh, it is so cool that we can learn so much about our solar system by studying these objects. Tarek, in order to study them, we have to find them first. How does NASA find and characterize these near-Earth objects?
So NASA uses powerful telescopes both on the ground and in space to find asteroids. And once NASA finds an asteroid, scientists calculate whether the orbit poses an impact hazard to Earth. Scientists also make follow-up observations with other telescopes to figure out how big the asteroid is and what it's made of. And all of this gets publicly posted on a website run by the Center for Near-Earth Object Studies at JPL Jet's Propulsion Laboratory so that people around the world can find out more.
Now, if we did find a hazardous asteroid, what would we do about it?
Well, believe it or not, as we speak, NASA is developing technology to deflect an asteroid so that it would not hit the Earth. One option is to park a spacecraft next to the asteroid and use the gravitational pull of the spacecraft to slowly nudge the asteroid into a different orbit. Another option is to actually slam a spacecraft into the asteroid and change its orbit that way. NASA will soon launch a mission called DART to test that particular technology. By developing this technology now, we'll be ready to deal with an asteroid if the time comes.
Okay, so Tarek just mentioned a mission to change an asteroid's orbit. It sounds like science fiction that NASA is going to crash a spacecraft into an asteroid, but let's learn more about DART.
Is NASA really crashing a spacecraft into an asteroid? Yes, NASA really is crashing a spacecraft into an asteroid. That spacecraft is DART, the Double Asteroid Redirection Test. Now, asteroids hit the Earth all of the time. Luckily, the ones that are big enough to cause widespread damage are pretty rare, and none are expected in the near future. NASA and others are actively tracking asteroids, but also, we haven't found all of them yet. So it makes sense to do this first test to demonstrate if we needed to protect the Earth, what might we do? And we should do this test before we need it. That's where DART comes in. DART is a spacecraft that's about the size of a vending machine, and it has really long solar arrays that stick out. And it's going to be traveling really fast, about 15,000 miles per hour. And it's going to slam into this target asteroid that's about the size of the Great Pyramid. So slamming this smaller spacecraft into this larger asteroid isn't going to destroy it, but it will deflect it. It's going to give it a small little nudge, and that will ever so slightly change that asteroid's future path. If you wanted to do this, you would want to do it years in advance, such that the asteroid and the Earth weren't on a collision course in the future. So is NASA crashing a spacecraft into an asteroid? Yes, NASA really is, in the name of planetary defense, in order to be ready in case we need it.
Okay, everyone, I see we have so many questions coming in from our online viewers. Remember that it is not too late to ask your questions. Just use hashtag AskNASA or drop your question in the comment box wherever you're viewing. Our first question is from Shanja Mani on Twitter, and they ask, why do asteroids float in space? Tarek, would you like to answer that one?
Sure. So asteroids are actually orbiting the sun. So the gravitational pull of the sun is the gravitational giant in our solar system, and the asteroids are orbiting the sun in the same way that the Earth is orbiting the sun, but in a different location.
Okay, so I have a new question. This one is from Rosebud on YouTube. They ask, will 2021 PDC hit Earth? I'm scared. Tarek, I understand that this is not a real asteroid, but was this name of the simulated asteroid used at this year's International Planetary Defense Conference? Can you tell us more about that exercise?
Yes, so as you just pointed out, 2021 PDC is a fictional asteroid. Every couple of years, the international community comes together to discuss how to respond if there were an asteroid that posed a hazard to Earth. And then this year, there was a virtual meeting back in April where there was an exercise with this fake asteroid, 2021 PDC, and decision makers and scientists from around the world worked together to practice and exercise what we would do in the event of such an asteroid threat. And you can actually tell it's a fake asteroid because its name and number don't match the system that we use for real asteroids.
All right. Well, Chase on Twitter asked, what are our planetary defenses against asteroids? Dani, would you like to talk about that one?
Sure, I'd be happy to build on what Tarek said earlier. So there is a couple of different ways that we are guarding our planet. One of the biggest ways is just keeping our eyes out on the sky and searching for asteroids that we haven't yet discovered. So there is a number of near-Earth object surveys, and they are doing this full-time around the clock at different locations on our planet, so they get slightly different looks at the sky. Other potential ways that we would mitigate against any sort of asteroid hazard include, testing some of the technologies that Tarek discussed earlier, using things like gravity tractors to kind of slowly change the path of these asteroids in space, as well as impacting them and potentially nudging their paths in space, like the DART mission will do in a couple years here.
Okay, well, I hope that answers your question. We have a new question from NASA on Facebook, and they ask, how do you know that they are really that old? Dani, can you share some insight on how old asteroids are?
Yeah, absolutely. So we have a couple of different pieces of information that allow us to draw that conclusion. One of the biggest sources of information about asteroids are actually meteorites that we get delivered to Earth through just natural impacts every year. And so we have a large number of meteorites in our collections across the world, and we can use those samples to do age dating and figure out exactly how old some of these samples are and when they formed. And that has given us insight into the fact that many of our meteorites really were born shortly after the formation of our solar system.
I have another question for you. This one is from Nick Georgiou on YouTube, and they ask, will an asteroid ever hit Earth and when? And will it be in this lifetime? Who would like to answer that one?
I can take that one. So the first thing to say is there are no known asteroid impact threats for the next 100 years. So that's the first thing. We do have asteroids that are smaller, say like about a few meters, maybe like 12 feet across. And those hit maybe once a year, but they break up in the atmosphere and don't cause a lot of damage. As Dani mentioned, our first defense is to find the asteroids. And right now we know about 40 or 50% of the asteroids that might cause like a regional damage. And so NASA is working really hard to find the rest of those asteroids, because once we know where they are, we'll be able to know more about the hazard they pose.
Okay. So I have another question from YouTube. This is from Radion AB. They would like to know, do asteroids have their own gravitational fields? Dani, would you be able to answer that?
Yes, I'd be happy to answer that. And the answer is yes, asteroids do have their own small gravitational fields. They are much weaker than Earth's. So we're thinking about things that are often more like microgravity when we look at asteroids like Bennu. And so they have a very weak pull compared to the larger planets in our solar system, but even they might have really small moons. In the case of Bennu, we saw many particles just a couple centimeters across orbiting around it in its weak gravitational field. It's a great question.
Steve Johnson on YouTube asks, will we potentially be able to use the materials found on asteroids as refueling stations for traveling deeper into space?
You want to take that one, Tarek?
Sure. So people talk a lot about what we call ISRU, or in situ resource utilization, which is using things on asteroids or on the moon, for example, to get resources like water or other things for astronauts or space exploration agencies to use. So it's an area of active work where people are thinking about how to utilize resources out there in space. But that, I think, is more of a long-term study rather than something that we can do right now.
Wow. Okay. We have a question right now coming in from Space Live on YouTube, and they ask if there is a difference between asteroids, meteorites, and comets, and if so, what are they? Dani, would you like to answer that one?
Yeah, I'd be happy to answer that. So there is a little bit of a continuum between what we think of as asteroids and comets, but typically asteroids are composed of more rocky materials, and comets, which originate further out in the solar system, are composed of different ices. But there's some asteroids that have a little bit of icy material, and vice versa with comets. And then as far as meteorites go, meteorites are the material that have from other planetary objects that have collected on our planet. And so we have a lot of meteorites from asteroids, but we also have some meteorites from the moon and even Mars. And so meteorites, again, just kind of refer to material from other planetary objects that originated elsewhere that has landed on our planet through the course of Earth's history.
Wow. I have a question from YouTube, and it's from RAFFAM567, and it asks, what is the most strange asteroid that has been analyzed?
I think that is a subjective question, and so Tarek would probably give a different answer than I would. I think some of the coolest asteroids that we have observed are asteroids in the outer asteroid belt that are part of the Themis family. And these are, I alluded to earlier, there's these objects, asteroids and comets are a little bit of a continuum. So there's some asteroids that display cometary activity every once in a while, meaning they show tails and like they're kind of off-gassing material. And I think those are really strange and fascinating objects, what we call active asteroids. Tarek, what do you think?
Honestly, I think it's whatever asteroid we have most recently visited, because every asteroid surprises. So thinking about like OSIRIS-REx, right? So we touched this asteroid and it behaved in a totally bizarre way, right? The whole surface moved away and the spacecraft kept going inward, totally surprising people in terms of their expectations of how the asteroid would behave. So every time we study a new asteroid, we get surprised, and I find the most recent surprise the most surprising and therefore the most interesting.
Nice. So I have a question from Nick Gurgu on YouTube, and they ask, NASA said that Adolphus won't hit Earth in 100 years. Does this mean in 100 years it will hit, or does it mean something else?
So I can take that one. So the asteroid Apophis, which was what was referenced, is an asteroid that in 2029 will make a close approach to Earth. It will not hit the Earth in 2029 or anytime in the next 100 years. In that really close approach to Earth, the orbit of Apophis and its spin state and rotation will change. And so that makes it challenging to predict what will happen really far in the future. But we know it's not going to hit for 100 years. We're not saying it will hit in 100 years, but we'll continue to study Apophis and measure its orbit and monitor it so that we understand the hazard that it poses. But to answer that question in short, NASA is not saying it will impact in 100 years. It's just saying we know it 100 years into the future and we'll continue to monitor it.
There's some really good questions coming from YouTube. We have Marco Ma 2010, who asks, why aren't the DART solar panels symmetrical?
Okay, so I can take the DART one. DART is testing actually a brand new technology called roll-out solar arrays. So think of like paper towels on a roll. And so the big solar panels you see extended out, they're like school bus size, actually on the spacecraft right now are wrapped up like around a paper towel tube. Well, it's not a paper towel tube, but that kind of an idea. And so when the spacecraft launches, it deploys. And that's just the way they were able to fit on the spacecraft. They've referred to it to accommodation. You got to fit a lot of stuff on the spacecraft in a really small space. And that's what benefited the design the most. But these solar arrays are brand new technology being tested for the first time on DART.
Tala on Facebook asked, how many asteroids are there in our solar system, and what are they doing? Are they helping anything?
I can take that one. So there are hundreds of thousands of asteroids in the solar system that we know about, and there are probably even more that we just haven't yet observed with our telescopes. And so they are, as far as what they're doing, most of them are just orbiting around the sun and sitting there waiting to be observed and examined by various telescopes, usually with instruments that give us some information about their composition and help us understand how they relate to other asteroids. Some asteroids, like I mentioned earlier, are what we call active, so they do have some sort of activity that's occurring on their surface. But a lot of them, like the other planets in our solar system, are just, chilling around the sun.
I have one last question, and it's from me. Maybe both of you could answer if we have a few moments. What advice would you have for viewers who want to pursue a career similar to your own?
Yeah, so I would be happy to answer, at least from my perspective. So I would say, study if you go to college, I would recommend that. Study something that relates to understanding the physical world around us. So, people think of math and physics and engineering, but also subjects like geology and even biology, especially because it has many applications to astrobiology, are great things to just begin understanding the world around you and questioning why are things the way they are and how did they get this way? What do you think, Tarek?
I think yes to everything you said. And then also looking for opportunities to get your hands dirty. So internships are a really great way to build experience that looks good on a resume. So while you're pursuing that important technical education, be bold and ask people for opportunities to do work, to do research, so that you can get that work experience and internship experience along with that formal education.
Thank you both for that answer to that question. And unfortunately, that's all the time we have. Thank you so much, Dani and Tarek, for joining us today.
Thank you, Bree. Thanks for having us.
Yes, it's been fun. Thank you.
Thank you. And thank you all for joining us from home. To keep updated about any of the exciting missions mentioned on today's show, be sure to follow NASA Solar System on Facebook, Twitter, and Instagram. To learn more about NASA's planetary defense efforts, follow Asteroid Watch on Twitter. And to learn more about how NASA is studying our solar system, visit solarsystem.nasa.gov. We are so happy you could join us today, but before we end our show, we have a very special message from NASA newest administrator, Bill Nelson. Until next time, happy Asteroid Day.
Hi, I'm Bill Nelson. I have the privilege of heading up NASA, and I want to thank you for joining us on International Asteroid Day. And every day for us at NASA is an asteroid day, because we have these missions that are exploring for asteroids all the time. As a matter of fact, NASA and our partners are watching the skies 24/7, 365, and using ground-based telescopes, we've already found 26,000 near-Earth asteroids. But there's so many more to be found. So today we announced the extension of NASA's NEOWISE. It's a space-based observatory that's going to help us find even more of these objects and work on NASA's first space-based telescope that is specifically designed to find asteroids, called NEO Surveyor. It's currently underway. We're also looking forward to the launch of DART. It's our first planetary defense test mission, and that's going to go later this year. Thank you for watching today's episode of NASA Science Live. You can be assured that NASA is always looking up.